All right, welcome back. So we were talking about concepts about variables, and we talked about very briefly about arrays, some of the limitations in arrays, some of the benefits of arrays. We also briefly talked about pointer variables. The pointer variables are special kind of variables. They allow us to point towards the memory locations. So they are faster. They allow us to access the data much quicker as compared to traditional variables or normal variables or regular variables, and also they are kind of indirectly connected to arrays. When I say that, why arrays and pointers say they have some kind of relationship? Anybody can tell me? There's some kind of implicit relationship between pointers and arrays. The name of this array, which is called num in this case, is actually implicitly a pointer variable. It's a reference. So for example, how do I display the data here? If I want to display the first element, how do I display the first element? What do? I use the name of my array, num. What do I do here in order to display the first element? So absolutely square bracket 0, so that will pick up the first element. I'll be able to display the value 15. Value 15. Now what if I simply say this? Cout num. What will be displayed? The address of that starting address of that array. So let's say starting address is 2000. This address is 2000. So that address will be displayed. So as you can see, array variable is implicitly a reference or a pointer. It's a pointer. So now we are making a connection that we moved on from a regular variable to array variable, and then we are making a connection with a pointer. Now, if you have not taken C++ before, some of you have not, you can also use a regular variable, like a variable like this one. You can also see the address, memory address of that particular location as well. So if I want to see the location of value variable, I can use ampersand sign value. Ampersand sign allows me to see the location, in this case 1000. In a real world, you will see the addresses in hexadecimal format, and we'll see a lot of addresses in today's demonstration as well. So it shows me the address of that location. And you say, well, why do I need to worry about the addresses? Why do I need to worry about addresses in regular variables, or arrays, or pointers? Because I stated earlier, it is faster, and you can access directly. You don't have to go indirectly. It allows you to access the data directly, and you can access the bigger part of the RAM, which is called heap. So it gives you more power. In fact, more complex systems, when they are developed by using some kind of pointers or some kind of references. So far, so good? So I'll be demonstrating this to you in a few minutes as well. Please go ahead. Question?
What's the difference between num and ampersand val?
So this num was an array. By default, it is already a pointer or a reference. So I don't have to use ampersand sign with num, because if I simply say display that one, it's going to show me the location of that variable. But with a regular variable, it's not a pointer variable. If I want to see the location of this particular value, 15, I have to use ampersand sign. Okay? So when you go over chapter 12, some of you probably would, so you will see you declare a pointer P, then it will show you equals ampersand sign some value. So you can assign a value, or your pointer can point towards that location. Now, a lot of this information is kind of overwhelming so far, because pointers are difficult concepts. They're difficult to grasp. They're not easy concepts. A lot of people do not like C++ because it gives you the raw power. It gives you at the same time some challenges, because with pointers you have a tendency to have a memory leakage. If you do not control or delete the pointers you have declared, they always exist in the memory. If you don't delete them explicitly in your program, they're holding on to the memory. When they're holding on to the memory, at one stage you will have memory leakage, which means your memory will be exhausted. So there are some issues associated with it, but we'll learn in chapter 16 and onward that how to ensure to destroy all these linked lists before we end our program. So there's a concept called destroy. In fact, we'll be using some functions, destroy functions. So you'll see one of the operations we'll be learning is destroying these linked lists when we are declaring them. Or destroy means releasing the memory back to the operating system, because when you're running your Visual Studio, you're holding on to the memory. So at one stage, once you're done using that part of the memory, you want to tell the operating system, you know what, I don't need this one anymore. Take it back. That's what the destroy means. We'll discuss most of these operations when we come back in the next lecture on Monday. So this is something just so you want to keep in the back of your head when you're reading chapter 16, that it talks about creation, talks about destruction, talks about a variety of other concepts. These are the concepts which kind of relate to the memory location. Yes, question?
Do linked lists not like uninitialize after you finish the program?
So we'll talk about nodes and linked lists in a minute. Then we'll learn how the data will be assigned to the linked list. So if you just give me a minute, we have not even talked about what is a linked list yet. So linked list is actually, let's go and get started on linked list. So if you go to your chapter 16, in chapter 16,